have some field in mind, because potential corresponds to a field. So let's say electric field and electric potential, to be concrete. Right? So now electric field is okay. We have an electric field, and the most characteristic defining property of electric field is if this electric field finds a charge somewhere, immediately it applies a force on that Q times E. That's the meaning of electric field. So we know that there is an electric field at every point. The directions are known, magnitudes are known, depending on what is the charge distribution. Now, consider this quantity. You have a point P here with a position vector R, and you have a point Q here, R1, and this is R2. These are points. These are just points. You have electric field in this whole space with some magnitude, some direction, depending on what is the charges, what are the charges which is producing this electric field. Okay. Now, if I construct a quantity, integration of E dot dr, I don't know whether I am going above the standard. If I construct a quantity E dot dr from P to Q, what does it mean? From P to Q there is some, let us say some line. I join P and Q by some kind of a cut. And I start from P, and then I go little bit ahead, and I say that this is my dr vector. And at P there is some electric field in some direction and some magnitude. And I construct this E dot dr. Then I move slightly more ahead, and then I say now this is my dr, then 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 this is my dr, and this way I keep going here and I reach here. I reach here, this is dr, then this is dr, then this is dr. And every time, if I am here, then this is dr, and at this point there will be some electric field, I do not know how much and in what direction, but there will be some electric field here. So I do this E dot dr and keep on adding all these things. Start with P, stop at Q. This is this quantity. Now this quantity has a very nice property, and that is you change the path. P to Q. And do this E dot dr, start from P, end at Q. And you end up with the same integration.
Yes.
You integrate and you find the same integration, same value. Once P and Q are not disturbed, then no matter what path you are taking,
Yes.
this integration all the time comes
Same.
comes the same. So it's very interesting property, interesting quantity, this E dot dr integration, and useful too. So we give it a name. We give it a name. And since it only depends on P and Q, the points P and Q, we say that this quantity will be V at P minus V at. We define a quantity V in the whole of the space, each point. P point, this is V. Q point, this is V. R point, this is V. S point, this is V. So that whenever you take 2 points and you do E dot dr on the path of your choice, starting from this point to that point, starting from this point, ending at that point, path choice is yours. You will get a quantity, and that can be easily obtained by subtracting this V at Q minus from V at P, right? This quantity we call potential, electric potential at P, electric potential at Q. At every point I have an electric field which has a direction, which has a magnitude. Similarly, we say that at every point I have a scalar quantity, a number, V, V at this point, V at this point, V at this point. And these two have relation. The electric field at every point and this potential at every point. There is a relation, and that relation exists.
Sir, I have a question. Sir, I have a question. Sir, sir.
10 सेकंड
Okay. Okay.
हमारी बातें सिंक हो जाए फिर गलत होंगे तो हम दोबारा निकलवा लेंगे. Okay, but this definition only tells me the difference in potential between V and P.
2 points.
It only tells me the difference. It doesn't tell how much was V at P and how much was V at Q. And we say that it doesn't matter. It's Vp minus Vq which is important. So you choose for one point, any point in the space, pick up a point of your choice and give it a number of your choice. You say that at this particular point, I dictate that the potential will be called 100 volt. Fine. But once that is fixed, then everything is fixed because the differences are fixed.
Yes. Potential, equipotential surface.
Height.
This is
Let's take an analogy. Height of the bulb is 4 meters. From where? From the floor, from the table, from the top of the board, from the top of this screen, from where? What do you mean by 4 meter? Differences have no uncertainty. The height of this floor and height of this roof, the difference has no uncertainty. If it is constructed to be 4 meter, it is 4 meter, 5 meter, it is 5 meter. But I can always say, no, I am not measuring from this 0th floor. I am measuring from the outside road. We have to go 5 steps below, then I get the ground level. So that is ground level. From there you measure everything.
Yes.
So this floor will have certain height, certain meters. This roof will have certain meters, but the difference will not change.
Yes.
You say, no, I live in, my room is in 2nd floor, that is the 0. No problem. You call that 0? Huh? The ground will be minus this much, roof will be the minus that much, but the difference has to be that same 4 meters which the mason has constructed. So in that spirit, we say that the potential is arbitrary to a constant. A constant. You can add a constant everywhere. Everywhere. Nothing will change. So in other words, you can choose your reference point. You can choose a point and declare that the potential of this point will be called 0. Now most of the time, but not always, most of the time, a point far away from all other points, blah 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 blah, which we call infinity, is taken as that reference point, but not always. If you have a capacitor plate, plus Q and minus Q, I don't take that as 0. The negative plate I take at the 0 and positive plate is V0. Right? Connect a battery, V0. Why should I take 0 at infinity? So not always, but in many of the cases we do this choice. So that's the relation between potential and the electric field. Incidentally, if you know electric field, you can calculate potential. And if you know potential, If you know potential, then you can also get electric field, because E dot dr will be minus dV. I wrote dP minus dQ to take care of this minus. And therefore your E, if it is in one dimension, Ex let us say, it is minus dV dx. And similarly Ey will be minus dV dy. And Ez will be minus dV dz. So if you know potential everywhere, if you know the potential everywhere, you can calculate the electric field. And if you know electric field everywhere, you can calculate the potential with one additive arbitrariness. So that means the same field can be described by capital E vector. Everywhere you tell me what is the electric field, which direction, what magnitude. Or you tell me the potential. I will do the calculation, I will get the electric field. So this quantity which we call electric field, entity which we call electric field, can be described either in terms of electric field vector or the potential which is scalar. Same thing. The benefit sometimes is that instead of using vectors to do all the calculations, if I am able to do it with scalars, the life is much simpler. And I am losing no information. I am losing no information. So that is the story.
Sir, I have a question.
आप कुछ कह रहे हैं?
Sir, इसीलिए sir, I want to ask that we talk about the total energy, and we talk about the total energy is kinetic energy plus potential energy, and there is nothing like potential energy term. We define it for our reference, and kinetic energy means the purpose in nature. The purpose is to change the kinetic energy, and work energy theorem is valid only under the work energy theorem will be valid only if non-conservative forces are zero. Sir, sometime so please elaborate this. In the today I did the question, but frictional force was there. It was non-conservative. Still, I was using COME. So, but where it should go, where should know conservation of mechanical energy. So according to that, I should not use that, because in non-conservative forces are there into the picture. I should not use it. We use conservation of mechanical energy in the gravitation cases.
आपका जो सवाल आप बता रहे हो, उसमें क्या रोलिंग थी या क्या था?
नहीं, सुबह वो जो रॉड थी ना, रॉड को हमने गिराया था 60 डिग्री पे गिराया था सर. हाँ
जी सर, यही वाला.
हाँ, तो वहाँ पे कंजर्वेशन ऑफ मैकेनिकल एनर्जी यूज़ कर ली मैंने. तो कर तो कि आंसर तो निकाल दिया, पर सर वो क्यों नहीं, मतलब
आत्मा ने गवाही नहीं दी.
आत्मा गवाही नहीं दे रही है. ये ग्रेविटेशन केसेस में हम यूज़ करते हैं वो.
See the example that you are telling, that there is a rod out here, and then this point is fixed. There is large friction so that it doesn't slip. As it happens.
Yes.
And then it's falling like this. So although there is a friction, the friction is not doing any work. Because your point of application is not moving. This point is fixed. It is rotating about this point. So the friction is not doing any work. There is no displacement in the direction of friction or opposite or at any angle.
Okay.
So the work by friction is not there.
It's not into the picture.
Is not in the picture at all. And therefore the kinetic energy plus potential. So there is no dissipation of energy in friction. Although friction is there, F equal to ma, in F equal to ma, that friction is contributing. Right? That friction is contributing, that is holding it, it's not allowed to slip. But that friction is not doing work. So you can still use that chemical, COME.
And sir, why I am defining potential energy? If the purpose is to if I am taking a ball और उसको ड्रॉप किया, तो काइनेटिक एनर्जी इनिशियल काइनेटिक is 0, so kinetic energy will increase. So I will have to say that something has if something has increased, then I will have to say that something has decreased. That is why I have said.
Not necessarily. Energy is not always conserved for this much of system. If it is not interacting with anything else, then yes. But if my system is interacting with something else, its energy is increasing. ठीक है ना? इसको मैं देखो ऐसे लेके ऐसे खड़ा हूँ मैं इसी हाइट के ऊपर, and then I start moving and changing velocity. So the kinetic energy of this guy has increased.
Yes.
Its potential energy is same mgh. So the total energy is not conserved. CUI में नहीं लगेगा.
मैं इसलिए भी तो नहीं
Yeah. So it's not necessary that if the kinetic energy is increased, some energy should be decreased. वो भी जरूरी नहीं है.
अच्छा वो भी जरूरी
वो
नहीं
भी
है.
जरूरी. क्योंकि देखो यूनिवर्स बहुत बड़ा है. पूरे यूनिवर्स का एनर्जी कांस्टेंट है और यहाँ बढ़ गया तो वहाँ कुछ घटा होगा ये वो बहुत लंबा चौड़ा किस्सा है. यू डिफाइन योर सिस्टम. इस सिस्टम में क्या हो रहा है वो देख लो. ठीक है.
But sir, even if we can't say that, it's not necessary to say that there is a potential energy. But if there is a change in kinetic energy, we must say that there is a work done by something.
हाँ work, the purpose of work done is to change the kinetic energy.
Theorem has to be valid in.
हाँ.
I mean, I don't know whether there are any exceptions to that.
Okay. True. True.
And I have
Sir,
a question on behalf of.
What is the example that
ये
work energy
आदमी
theorem?
कुर्सी को पीछे पक्के बैठी हुई है. बिल्कुल हिल नहीं रही है. So since we had the discussion of Newton's second law and first law, now the third law, when it is not valid.
When it is not valid,
हाँ.
it has nothing to do with inertial or non-inertial
Right.
frames. But there are situations in which Newton's third law itself is not valid. Okay? Because Newton's third law is based on the fact or assumption that the two objects A and B, if they are exerting forces on each other, this force does not depend any kind of history. It depends only on the positions, and the forces are towards each other, and many things, several things. From there, it is based on that. So if the kind of forces that we are dealing with, normal force, tension in the spring, gravitational force, electrostatic attraction, even electrostatic interaction is risky. So एक बार उसको switch कर दो. So इसमें लगेगा. In these kind of situations, Newton's third law will be used. But wherever field comes into picture, wherever field, electric field, magnetic field, when fields, if the force, what is Newton's law? Force exerted by A on B is equal and opposite to force exerted by B on A. Many situations we say that A never exerts any force on B. Yesterday or the day before I was telling that the job of Q1 is not to exert force on Q2. There is no mandate given to Q1. Apply force on Q2.
Yes.
It has come in your vicinity. At a distance R. Apply a force. Q1 Q2 by 4 pi epsilon naught R square. No. Q1 has nothing to do where Q2 is, whether it is there, whether it is not there, how many other charges are there. Q1 has nothing to do with this. So Q1 does not apply force on Q2. But force is there. There is attraction or repulsion. Force is there. Someone has applied force on Q2. If they are of equal polarity, nature, this is positive, this is positive. I place it and leave it. I am holding it and I am releasing it. it goes away.
Hmm.
So someone has applied force, and only because of this Q1, if I remove the Q1 and then release this Q2, it doesn't go anywhere. Okay. But then we say that, see, the job of Q1 is to create electric field everywhere, irrespective of whether other charges are there or they are not. So Q1 had created an electric field at the place where you are bringing this Q2 or where the Q2 is situated. And it is this electric field which is creating force on Q2. So
Yes.
particle A is not exerting force on particle B.
Yes.
Particle A is creating a field
Field.
everywhere,
Yeah.
and that will be created irrespective of whether that Q2 is there or not, or
Okay.
Q3
K
is there
Q
or
by R
not.
square. Yes.
And this electric field exerts a force on B.
Yes. Definitely.
So the very statement of Newton's law, third law, if A exerts a force on B, B will exert equal and opposite force on A, becomes meaningless.
Meaningless.
लॉ में
Yes.
भी यही बताते हैं, सिर्फ दो चार्जेस लेते हैं तो फील्ड की बात नहीं होती, और फिर हम उसमें ये भी कहते हैं कि इट ओबेज न्यूटन्स थर्ड लॉ कि Q1 Q2 पे फोर्स लगा रहा है एंड इक्वल एंड ऑपोजिट फोर्स.
हाँ एनसीईआरटी में है ना, एनसीईआरटी में थर्ड लॉ लिखा हुआ है ना. हाँ थर्ड लॉ का रेफरेंस दिके उसे वैलिड बताया हुआ है.
ठीक बात. So, if bringing field is necessary, if bringing field is necessary in some situations, उसके बिना काम नहीं चल सकता. पार्टिकल ने पार्टिकल पर फोर्स लगाया, उससे अगर काम चल जाए तो अब मत लाओ फील्ड को बीच में. Right? If your situation is such, that you say that this particle Q1 has exerted a force on particle Q2. The magnitude is Q1 Q2 by 4 pi epsilon naught R square. If R changes, it will change according to this, and this is the direction. In this direction, the force is created. In certain situation, this description works. And then you can talk for such situations in terms of Newton's third law. But there could be situations in which it will not. नहीं कह सकते ना. Just like आपने सुना होगा that space time curvature, general theory of relativity. Don't go into the details of it, but qualitatively तो सुना you must have heard about this. There is no gravitational attraction in that, according to that theory. And they say that if you have an object in the space, heavy object, then it creates a curvature in the space-time. So this is the space, empty space, and you have time. So in some way they define something called space-time. Where space is there and time is there,
Yes.
and they define one single word, space-time, whatever, but it is made up of space and time. And then they say that this space-time has become curved. Peculiar things. I don't understand, you also don't understand, don't worry, we are on the same page.
Correct.
But now since this earth has created this curvature in the space-time, then it's something like this. It has, the space-time is curved like this. Say if there is an apple, then it just rolls down the curvature. The earth is not attracting. The earth is not attracting the apple. The earth has made this space-time curved. And therefore the things want to roll down wherever the curvature takes them, and therefore it appears to come towards this earth. The apple, everyone sees that apple is falling on the earth. They said, yes, apple is falling on the earth, but not because the earth has exerted a force on the apple. But because the earth has curved the space, it was happily lying there. But now the whole space-time is curved, so it has to roll down the curve, and therefore it appears to it comes towards this earth. It is coming. It is coming. That's an observation. That's an observation. But it's not because it has created a force on that apple. It's because it has created your earth like space-time like this. And then if you release it from here, अर्थ पे आके टकरा जाएगा. Now, and there are compelling situations, experimental situations, actual observations. Cosmology तो वो बताएंगे better. It's not cosmology as such, but still close to that. There are actual situations in which this attraction model, gravitational attraction model, this every two particles M1, M2 attract each other, doesn't work. If you derive some result from this and you see actual what is happening, they are different. And you take the curvature theory and that comes out well. So this attraction, in a blunt language I will say that, no, attraction theory is wrong, curvature theory is correct. लेकिन जो ऋषि मुनि मनीषी ज्ञानी ध्यानी बहुत सारे मेडिटेशन कर सकते हैं, दिव्य ज्ञान जिनको प्राप्त है, वो काम वही कर सकते हैं. वो कर्वेचर को समझने का और उसके अनुसार कैलकुलेशंस करने का काम वही कर सकते हैं. ओनली वेरी elite persons having a lot of experiences, only they can work with that curvature theory. And if we are not concerned with what is happening there, if we are concerned if this apple falls, will I be able to pick it up or not?
Definitely.
I need not go to the curvature theory. I will be happy with this Newton's law of gravitation.
Yeah.
And I'll say, who says it doesn't work? It works. Okay. Similarly, there are situations in which this particle exerts force on the particle. It works well. The third law will work well. Everything will work well. But there are situations where it is not. In that case, Newton's third law will not work.
The third law will not randomly.
In electrostatics also there is actually cases where this may not hold. Like
अब आप देखो, it's simple. Suppose I have a charge Q1 here and a charge Q2 there.
लेकिन मूविंग चार्ज पार्टिकल या एक्सेलरेटिंग चार्ज पार्टिकल की ये शायद नहीं वाली होगा, क्योंकि जो गिवन है एनसीईआरटी में भी एक कंटेंट गिवन है इससे रिलेटेड बिगनिंग में ही.
Suppose you have a charge Q1 here and a charge Q2 here. Nothing else in the world. We are also not there. So how much is the force on this? This distance is r, let us say. The force on this is Q1, Q2 by 4 pi r square, epsilon naught r square. Okay? Very nice. And suppose this distance is quite large. Suppose it is 1 light year. Today, on 30th of December 2024, I shift this charge.
Good.
This charge is shifted here on 30th December 2024. No information can travel with a speed greater than
Speed of light. Yes.
So this poor guy will not know for 1 full year that something happened here. So entire 2025, it will still feeling this force. The force on Q2 remains this much for the entire 2025.
30
And
December.
this distance is not r square, r. This distance is not that r. That r has increased. I increased by just 5 centimeter or 1 meter or so. So in comparison to that 1 year, this has taken few seconds only, or even a split second. But this has happened on 30th December 2024. Will be known to that Q2 only 30th December 2025. So this entire year, the force is Q1 Q2 by 4 pi epsilon naught r square, and r has changed. R has changed, but it still is stuck to that same force. But now here is the more interesting point. This Q2 had created a field E here and had created a field E prime here. Already. These charges were placed in 2023 and they were lying happily there till 30th December 2024. So there is, because of this Q2, there is an electric field E, and here there is an electric field E prime, which is smaller than this E, because this distance is larger. The moment Q1 reaches here, it knows that the field has decreased, and so the force has decreased. Huh? Because this Q2 is there for quite some time, right? So it has created a field here, a lower field here. When this Q1 was shifted, already it was lying in the larger field, it moved to the smaller field. Immediately the force decreased. So for the full 2025, the force on Q1 and force on Q2 have different magnitudes.
सर लाइट ईयर इनफाइनाइट नहीं माना जाएगा, आर की वैल्यू
वो आपकी मर्जी है.
इनफाइनाइट
I am a mathematics person. I am a mathematics person. मेरे लिए सब इंफिनिटी का मतलब मेरा इंफिनिटी होता है. ये क्या मतलब है? आप एक फाइनाइट नंबर को इंफिनिटी बोल रहे हो? थोड़ा गरिमा का ध्यान रखो इंफिनिटी का. दिस इज एन एग्जाम्पल. आप 1 लाइट ईयर मत लीजिए ना, आप बहुत थोड़ा सा समय ले लीजिए, थोड़ी सी डिस्टेंस लीजिए, थोड़े से टाइम के लिए वो वेरिएशन होगा. इसका फोर्स दूसरा, इस पे फोर्स दूसरा. Action at a distance. So if you are okay with action at a distance, if the situation is such that action at a distance gives me the same result as the field gives, then you can use this Newton's third law. Otherwise not.
Third law में action and reaction has to be at the same instant of time, na? When we are talking about this light.
Yes.
Yeah, I'm talking of one single instant. 30th June 2025, 6:05 p.m. This is one instant. At this instant, what is the force here and what is the force here? What is the force on this and what is the force on this? At the same instant, the force on this is large, the force on this is small. They are not equal. Huh? But don't worry about these exotic situations. Most of the time we are okay with Newton's third law. Most of the times it's okay, we can. But sometimes it so happens that the field effects do show up, and this force by one particle on the other particle, Newton's third law, sometimes doesn't happen. Magnetic field, when magnetic field comes into picture, similar story. When magnetic field, and QV cross B, Yet another problem.
This was my question.
Right?
तो मतलब मूविंग चार्ज पार्टिकल मैग्नेटिक फील्ड पे कोई फोर्स लगा ही नहीं रहा, फील्ड पर कोई फोर्स नहीं लग रहा, फील्ड चार्ज पर फोर्स लगा,
हाँ, फील्ड पर कोई फोर्स नहीं
फील्ड
लगाता,
पे कोई फोर्स नहीं लगा,
लगाता ही नहीं
है
है,
ना?
कभी नहीं
इसका
लगाता।
मतलब वहाँ फील्ड और चार्ज की इंटरेक्शन होगी नॉट,
ये फील्ड चार्ज पर फोर्स लगाता है।
तो चार्ज फील्ड पर नहीं है,
चार्ज।
न्यूटन थर्ड लॉ इज नॉट वैलिड।
हाँ, अगर आप फील्ड को एक एंटिटी लोगे तो यस।
सिमिलरली यदि चेंजिंग मैग्नेटिक फील्ड के कारण इलेक्ट्रिक फील्ड बनी है और फिर वो फोर्स लगा नहीं इस चार्ज पर, पर ये यहाँ पे नहीं लगा, फील्ड पर नहीं लगा।
तो फील्ड पे तो फोर्स लगता है।
फोर्स लगाने के लिए कुछ मटेरियल होना चाहिए एंड दैट्स अ फील्ड।
फील्ड पे फोर्स नहीं लगता
फील्ड
है।
पे नहीं, वैसे भी नहीं लग
हाँ,
सकता।
मतलब फिर दो चीजें आपस में ये खत्म हो गई।
अगर तो इलेक्ट्रिक फील्ड मैग्नेटिक फील्ड भी एक साथ करेंगे तो वो भी आपस में फोर्स नहीं लगाएंगे।
लेकिन हम फील्ड पे भी नहीं जाते। What our examples even for two material particles.
अच्छा फिर ये जेई प्रॉब्लम हो,
जय में नहीं आएंगे ऐसे प्रॉब्लम। जय वाले इतने दुर्दांत नहीं होते हैं। See, JEE people are very student friendly. We work very hard to make simple the paper simple, understandable, nothing to be remembered much. हम सब दे देते हैं यहाँ पे।
डायग्राम एक्सप्लेन कर देते हैं।
डायग्राम भी एक्सप्लेन कर देते हैं। आप सोचो ना जरा। आप सोचो। हाँ, वैल्यूज भी दे देते हैं। नंबर्स भी याद नहीं
ऑप्शंस
रहता
भी
होता
दे
है।
देते हैं, ऑप्शंस भी।
हाँ, अब आप थोड़ा सा सोचो, अब उसको लोग कहते हैं इतना हार्ड क्वेश्चन क्या है?
सर लेवल कर्व रोड पे हम कहते हैं कि फ्रिक्शन से ये पूछना है कि कौन सा फ्रिक्शन सेंट्रीफ्यूगल फोर्स प्रोवाइड करता है। लेवल कर्व रोड पे जब हम कहते हैं कि
अच्छा, level road
हाँ जी सर, लेवल रोड
Circular.
मतलब बैंकिंग से पहले का एक टॉपिक है लेवल कर्व रोड।
हम्म।
सर उसमें हम निकालते हैं कि व्हाट इज द स्पीड जिसके बियॉन्ड कार या व्हीकल जो है वो स्किड कर
स्किड हो
जाएगा।
जाएगा।
तो सर इसकी एक्सप्लेनेशन
रूट म्यू आर जी वाला, म्यू आर जी
म्यू
वाला,
अंडर रूट
रूट म्यू आर जी वाला,
एक्सप्रेशन लेस
आर जी टेन थीटा।
लेस देन। तो सर ये
वो बाहर ले जाता है ना।
हाँ हाँ जी सर, we derive that expression na Vs should be less than equal to mu s r g, v maximum V should be less than equal to mu s r g। तो इसी का कॉन्सेप्ट
तो म्यू एन इज इक्वल्स टू एम वी स्क्वायर बाय आर कर देते हैं ना हम, है ना? कहाँ गया?
स्टैटिक क्यों आया?
स्टैटिक क्यों आया या इन जनरल व्हाट वाई डू वी टेक लेस देन इक्वल टू?
Okay, so if it is going in a circular path, right, then there has to be a real force towards the center. So होता क्या है, your wheel is rolling on this. तो वहाँ तो static friction है, but then if you are trying to curve, then can I go in non-inertial frame? That will be easier.
सर दोनों बता देना, क्योंकि सर एक्चुअली होता क्या है कि हम लोग उस टाइम पे नॉन इनर्शियल की टर्म्स में स्टूडेंट्स को
हाँ,
नहीं
ठीक है,
बताते।
ठीक है, पहले non-inertial
हाँ
में
जी,
सीख लेते हैं.
हाँ जी।
So what we do is, this is the track, here is this is the car which is going this way, and this radius, this is taken as the x-axis and corresponding y-axis and then x. As the car moves, my axis also rotates as seen from the road. So this is x-axis, this is y-axis. And when the car reaches here, this is my x-axis and this is my y-axis. So that is why I am calling it a rotating frame. My x-axis, my y-axis are not fixed as seen from the road. Road is the inertial frame of reference. Road is the inertial frame of reference. But I do not want to use it now. And I construct another frame in which origin is at the center of this path, but x-axis is along the line joining the center and the car, and therefore this x-axis keeps rotating. And in the same plane, if your y-axis, then correspondingly that also rotates. Z-axis could be perpendicular, that can stay same. So this is our frame. In this frame, since it is rotating, a pseudo force is there. So here, the pseudo force on the car there are certain rules to know how much pseudo force I have to apply. Here the rule is that the pseudo force, suppose the car is here, then you have to apply a pseudo force here, which we call centrifugal force, centrifugal, and that is mass times omega square times r. This is the this is a pseudo force because I am using a non-inertial frame. This is m omega square r, and its direction is this direction. So you can write in a vector notation also, but it is outward. This direction. Okay. Now this force, if the friction is not in the picture to start with, this force will, my wheels are like this, my car is like this, it's going ahead, but this force is radially outward. It will try to slip my car, skid my car on this, in this direction, outward direction. Once I have taken the pseudo force into account, I am entitled to use Newton's second law. Right? I have paid the registration fees. By taking the pseudo force also in our list, by clicking this, you agree to. Right. So by taking this pseudo force into account, now I can use F equal to ma. Usual physics, usual geometry, everything. So since the force is this way, so the car will slip. The wheels are like this, but the car will slip in the perpendicular direction. So the frictional force will come into picture to prevent that slipping, as usual. So the friction coefficient is there. So for stopping this slipping, friction will be in this direction. So friction will be in this. This will be the friction. Okay. And these two balance each other in my frame. If the friction is not sufficient, if this m into omega square into r, the centrifugal force is large, because that depends on omega, at what speed I am driving the car. If you drive it at a large speed, omega will be large and omega square will be large, and friction will not be able to provide that. The maximum possible is mu times n. N is mg, vertical direction, no motion. So if mu is less, skids. So from there you can obtain your value, maximum or minimum value of mu, which is needed for that particular omega, that means that particular speed. So the life is very simple. Otherwise you will still say that since it has to go in a circular path, now I am talking from inertial frame, since it has to go on a circular path, who will bend it? I have put my steering, turned the steering, all those things, fine. But the steering does not bend the car.
Centripetal.
Is the external force needed. Okay, to create acceleration in a system, there is an external force needed. तो आप अपना वो जो भी वो ऐसा वैसा करते हो उससे कुछ नहीं होता है. उससे you instigate, you request the road to apply friction, but ultimately it's the road which will decide whether to be obeyed or not to be obeyed. If the friction coefficient is much less, the road will say bye bye.
Go out. Go out.
So आपने स्टीयरिंग ज्यादा घुमा दिया तो आप जाओ
Skid.
स्किड करो
Skid हो जाओ.
आपके मन.
बहुत अच्छा.
So if I'm from inertial frame of reference, I will go this way, that since by turning the car, उसका जो भी मैं हैंडल कुछ करता हूँ, उससे I have already ensured कि वो घूम जाए. But वो घूमेगा नहीं, वो तो सीधा जाएगा ना.
So problem ये
तो इसलिए फ्रिक्शन आता है.
Hmm.
फ्रिक्शन कोफिशिएंट है और उसको जाना सीधा है. फर्स्ट लॉ है. तो आपने तो घुमा तो दिया लेकिन एक्सटर्नल फोर्स है ही नहीं मान लो. एक हॉरिजॉन्टल में मान लो है ही नहीं, फ्रिक्शन ही नहीं. सो इट विल गो स्ट्रेट.
घूम ही नहीं पाएगा.
जाएगा
घूम ही नहीं पाएगा.
तो स्लिप करेगा. तो स्लिप क्योंकि ऐसे आपने घुमा के चक्का रखा हुआ है तो स्लिप करेगा. और स्लिप करेगा तो फ्रिक्शन चूंकि कोफिशिएंट है, इट विल कम इनटू पिक्चर, इट विल बेंड द होल कार. And that friction should be equal to mass times acceleration. Okay, I'm talking of from the ground frame. So just with real forces, I see that it is going in a circular path. So that the acceleration is v square by r or omega square r. So the friction should be able to provide that much of force so that it can turn. ऐसा करके आप उसको बता दीजिए.
सर प्रॉब्लम मैं अगर सिर्फ बोलूँ इसमें, जैसे आपने नॉन इनर्शियल फ्रेम का बताया तो उसमें तो गाड़ी बाहर स्किड हो रही थी तो हमें दिख रहा कि फ्रिक्शन इस डायरेक्शन में लगना है ऑपोजिट टू द स्किडिंग. लेकिन इस केस में हम कह रहे हैं कि टर्न करने के लिए हमें सेंट्रीपिटल फोर्स चाहिए अंदर. तो अब यहाँ पे फ्रिक्शन की डायरेक्शन कैसे हम लेकर आए सर? ये
तो
maybe
नहीं
सिर्फ-
दोगे ना.
हाँ,
अगर नहीं दोगे तो किधर स्किड करें. मान लो फ्रिक्शन हमने नहीं दिया और हमने
टेंजेंशियल
सीधा जाना चाहेगा ना, तो वो किधर स्किड कर रहे हैं. आप देखोगे अगर केंद्र से बैठ करके देखोगे तो आउटवर्ड स्किड कर रहा है ना. तो इनवर्ड फ्रिक्शन
ठीक है.
एंड दैट इनवर्ड फ्रिक्शन विल टर्न द होल कार सो दैट वो स्किड नहीं करेगा. इसी रेडियस पर चल रहा है. हाँ.
सर potential energy negative means force of attraction.
नो
नहीं
आगे बोलिए.
नहीं बस ये एक लाइन थी क्योंकि बहुत डिफरेंट कॉन्टेक्स्ट में हम इसकी बात करते हैं. लाइक ग्रेविटेशन में स्पेस फील्ड पढ़ते तभी हम कहते हैं पोटेंशियल एनर्जी नेगेटिव है. और प्रोटॉन के स्ट्रक्चर्स में भी जब डोल नेचर और ये सब पढ़ते तभी वहाँ पे भी नेगेटिव की बात आती है. बट उसमें पोटेंशियल एनर्जी बहुत सारे ग्राफ्स देखे हमने.
du by
ये
du.
छोटा सा
See, a unqualified statement that if the potential energy is negative, the force will be attractive. इसलिए ये मीनिंगलेस है क्योंकि मेरे को हक है कि मैं किसी भी पोटेंशियल एनर्जी को पॉजिटिव कह दूं, नेगेटिव कह दूं, 0 कह दूं, 100 कह दूं, 200 कह दूं, 10 कह दूं, 0.5 कह दूं. तो मेरे को हक है ना एक पॉइंट के लिए. बाकियों का तो फिक्स्ड हो जाएगा because the differences are well defined. तो उसमें क्या है, आप जिसको +100 कहते हो उसको मैं -100 कर दूंगा 200 कम करके. जिसको आप +50 बोलोगे उसको मैं 200 कम करके -150 बोल दूंगा. जिसको आप 500 बोलोगे उसको मैं 200 कम करके 300 बोल दूंगा. Nothing changes. So potential energy being negative will not tell me anything. It's the difference of potential energy. It's the difference of potential energy which matters. So अब आप पूछो कि if you come closer, whether the potential energy is decreasing or increasing.
When you come closer,
If you come closer, whether the potential energy is decreasing or increasing.
sir, it depends na. on the field in which we are talking.
It does. It does. तो मैं इसीलिए कह रहा हूँ.
Depends on with
हाँ, इसीलिए तो
respect
कह रहा
to
हूँ whether it is increasing or it is decreasing. तो क्या होता है कि एक मिनट जो फोर्स है वो हमने अभी वो इक्वेशन क्या लिखा था dv is equal to minus f dr वेक्टर में लिखा था मान लो हम x में चल रहे ऐसे था ना ये था ना राइट सो मान लो हम हाँ हाँ ओके ई फोर्स पे ले लेते हैं
फोर्स पे ले सकते
तो ये फोर्स का बात कर रहे हैं
डी है डी
हाँ फोर्स का बात कर रहे हैं ना तो हम फोर्स ले लेते हैं पोटेंशियल एनर्जी कह देते हैं यू कह देते हैं एंड देन दिस विल बी फोर्स ठीक है एक्चुअली डॉट दिया है बट एक ही डिमेंशन में ले रहे हैं तो मान लो ये मेरा ओरिजिन है यहाँ पे कुछ बैठा है जो फोर्स लगाता है और इसके ऊपर फोर्स लगाता है ये मेरा पार्टिकल है P और ये है Q और ये नाउ सपोज द फोर्स इज इन दिस डायरेक्शन it comes from here to here the potential energy has decreased du is minus f dx